I'm trying to join this metal tube to a thick metal base. If I use a standard soldering iron, the iron can't generate enough heat to melt solder onto this large thermal mass. The solder just beads up and falls off. It's completely ineffective. I need something much more powerful, and I've got just the idea. I'm starting with a soldering iron. I'm going to completely disassemble it. I'll unscrew the handle and remove the internal heating element and the standard tip. We won't be needing these parts because we're going to bypass the delicate electronics entirely. Next, I'm taking two thick, heavy-duty red electrical wires. This is crucial because it needs to handle a massive amount of current. I'll strip the insulation off one end. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Then, I'll securely attach this exposed copper directly to the metal tube of the soldering iron. A tight connection here is vital to prevent resistance and overheating. I will insert the tip of the soldering iron through the copper pipe and tighten it. Once it's secure, I'll reassemble the plastic handle. Now for the other end of our heavy-duty red wire. I'll strip the insulation and attach a sturdy alligator clip. I'm carefully crimping it to ensure a solid electrical connection. This clip will allow us to easily connect our new tool to a power source. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. To make the welding electrode, I'm using a welding rod. I'll insert it into the tip holder of our modified soldering iron and tighten the screws firmly. This rod will concentrate the electrical current, creating the intense heat needed for welding. Every welding setup needs a ground. I'm taking a thick white wire and attaching alligator clips to both ends. This will complete the electrical circuit, allowing the current to flow from the power source through our tool into the metal and back again. For power, I'm using two 12-volt car batteries. First, I'll test them with a multimeter to ensure they have a good charge. The first one is reading around 13.4 volts, which is great. The second one is a bit lower, around 13.2 volts, but it will still work for our purposes. To get the voltage we need for an arc, I'm connecting the batteries in series. I'll use a short jumper wire to connect the positive terminal of one battery to the negative terminal of the other. By wiring them in series, we combine their voltage. Let's test it. Perfect. We have over 26 volts of potential energy ready to go. It's time to hook everything up. I'll connect the red cable of our custom welding tool to the positive terminal. I'll attach the grounding cable to the negative terminal of our battery bank. We are now live. I'll clamp the ground wire to our metal base and position the tube. Now, watch closely. By touching the electrode to the joint, I complete the circuit. The high current creates an electrical arc, generating intense heat that instantly melts the metal, fusing the two pieces together. I'll make several spot welds around the base to ensure a strong hold. After letting the metal cool down, it's time to clean up the weld. I'm using a hammer to chip away the slag and a wire brush to scrub the surface clean. This reveals the solid fused metal underneath. Let's test the strength of our weld. Look how perfectly it works. I can bang it against the table, and it holds strong. This homemade spot welder is incredibly effective. If you enjoyed